recording and share my screen. And again, we'll be typing these all into the terminal, seeing what the actual answer is. And I trust you all to grade yourselves honestly. And if at any point as we're working through the answers here, you have questions about anything, then feel free to interrupt me and ask those questions. So problem one here about piping and grep. I'm going to switch over to our terminal here. And let's go ahead and do the reset command, clear things up. And I'm going to do something a little bit different with these first 4 commands up here, just something that we'll need later today, and it'll make going through the quiz just a little bit faster. And that's that you can use semicolons to run multiple commands at the same time in the terminal. So here, if I do cd semicolon rm space dash rf quiz semicolon make dir quiz semicolon cd quiz like this, you can see that these 4 commands right here are the same as the 4 commands in the quiz. Same as these 4 commands, but it's just on one line. So that'll make it easier for me to rerun it later. And your future quizzes will all have these things combined on one line. So I hit enter, just ran these 4 commands one after the other. Here we're now in our quiz folder, and there's nothing at all in that folder. So I've just run these first 4 lines here, combining them into one. Now we have line 5, 6, and 7, 3 echo commands in our 3 different languages, all doing the append double greater than sign over here into the README file. So it's hello, then hola, then salve. So echo, hello world into README, echo, hola mundo into README, and all of you should double check that I'm not making any typos here. Salve mundi into README. And so that brings us up to these 3 lines. And now the final line, we're going to output the README file. Cat README right here will output all 3 of these lines, one after the other, because they're all contained. They were all appending over here. So I'm not going to quite output the last line yet. I'm not going to do the pipe. We'll just verify that cat does contain all these 3 things in here. And then recall that the pipe operator takes whatever the output is on the thing on the left and passes it to the input on the thing on the right. The thing on the right over here will filter the input, looking only for things that match the regular expression right here. In this case, we have a very simple regular expression of just the letter E. So any line that contains the letter E will get matched and printed out. So up arrow back to that, pipe grep letter E, hit enter, and we get hello world and salve mundi, just no hola mundo. Any questions about the first problem? Okay, for problem number 2, rather than doing the reset command here, I'm just gonna give us hit enter a bunch of times. Sometimes I find that useful when I'm working in the terminal. If I don't want to like totally reset everything, but I still want to have a kind of break between different sections of my terminal session, I'll just hit enter a bunch of times, and that'll give me this big green block to let me know there's different things going on. And I'm going to use the up arrow to come back to my big long cd command here. There's the first 4 lines of problem 2, and hit enter, and we'll see that that totally reset our quiz folder for us. So back over here to problem 2. Did the first 4 lines already. We just have 5, 6, and 7 left. So the var command here, the var variable, and I'll be extra careful to make sure that I type this in right, but you all should be extra careful to make sure that I don't make a typo here. I think that's correct. I don't see any hear any shouts of horror, so I think that's correct. And then over here on the touch command, we have var inside of quotation marks, touch var inside of quotation marks, and they're double quotation marks. So again, the double quotation marks, variable expansion occurs inside of double quotation marks, but then this entire thing will be treated as a single parameter, a single thing getting passed to the touch command. So there will only be one file created, that is whatever the output of this command right here is. I do that. And then the very last command for us, counting the number of files, ls pipe w, ls pipe wc-l, and we get the 1, which is just the echo, which is the output of all of this stuff here. Why do we only get one file here? Why is all of this evaluate to just echo? It's because here, so you always work from the inside out. This command right here calls the echo command with no parameters. So echo prints out nothing, just a new line right here. So there's nothing that gets passed as another parameter to this echo from this right here. This basically goes away. But we do have this echo right here that will get passed as a parameter here. The fact that it's in single quotation marks is meaningless. Could have taken away those quotation marks and it would have been totally okay. And so this is the only thing that gets passed to this echo. So this echo just prints this out, stores the word echo in this variable right here. We touch that word echo and it creates that one file for us right here. Any questions about problem number 2? Problem number 3, big long for loop. So let's come back here. Let's add some blank spaces. Let's rerun my big long CD command. I use the Control R right here to search back through my history and then just type CD, hit enter back over to our file thing here. So for file in AB echo C space D E space F do, and then we're touch $ file done like that. Does anybody see a typo? Looks good to everybody. Hit enter. And then the very last command down here, number 6, just counting again how many files got created. ls pipe wc-l, and we get that there are 6 files created. Run ls, we get these are the 6 files, a, b, c, d, e, f, all the individual letters created as individual files. The reason for that is here when we do the, again, always work from the inside out in this double quotation marks right here. We run this echo command and substitute the results into the double quotation marks. So this echo command here will give us just the C space D as output. And so this quotation mark right here is really A space B space C space D. This is the first entry in our for loop. We'll first do this thing, and then we'll do this thing over here. So the for loop itself only goes through 2 times. But when we do the touch over here on this file parameter over here, notice there are no quotation marks around this file variable. And so this file variable gets expanded to A space B space B, C space D, all 4 of those first letters, these 4 letters here corresponding to this quotation mark right here. And the touch command, and in general, every command that operates on files, if you pass in more files, more parameters than just one, it will do the same thing to all of those parameters. And so even though this touch command is only one once, it's run with 4 separate parameters. And so it creates 4 separate files the very first time through. The second time through, we have EF, and the same thing happens. There are no quotation marks around here. So this EF gets expanded to 2 separate parameters for touch, and it creates 2 separate files. So that's why we get 6 files right here. If instead of having no quotation marks around the file, I use the double quotation marks like this, then we would get only 2 files, a file like this and a file like this, because we run through here only 2 times. But there's no quotation marks, so we get 6 files. Any questions on problem number 3? Yes. Either you're running on your local computer and not the Lambda server, or you're running or there's a typo in there somewhere. So I'm gonna real quick redo this entire thing, do that CD. Now there's nothing in here. Now rerun this for loop, adding the double quotation marks around here like this. If I do ls, you can see that this and this are the two separate files. ls, when there's spaces in a file, we'll put the quotation marks around it to identify that these things go together and it's not different files. And when you do ls-wc-l, we'll get the two. So with the quotation marks, we get the two. Redelete again, rerun without quotation marks. Without quotation marks, we get 6. If you still have a question about that, I can take a look after class about what's happening. Okay. Yeah, so again, if you're doing working on your own computer, you're using probably, if you're on a Mac, you're using ZSH. ZSH is, and in particular, your touch command is not a GNU command anymore. It's going to be the BSD version of the command, and it's going to be behaving differently. So that's what the cause of that was. But good question. Any other questions on problem number 3? Yes.
Can you ever like touch the file and then have a $sign?
Question is, can you have a $sign within a file name? And the answer is yes. I'll go ahead and reset everything so there's nothing in this folder. Come up here, rerun this, and let's use single quotation marks now, like this. Single quotation marks do not get expanded. Variables do not get expanded inside of here. So even though this is going to run through 2 times with 2 different file parameters, this will not get expanded, and touch will always get as its parameter $sign file like this. Hit enter, type ls, and we have only one file whose name is literally $sign file. On every operating system has slightly different requirements about what letters you're allowed and not allowed to have in file systems. Unix operating systems and Linux in particular are the most permissive, and the only character not allowed in a file name is the / character. And the reason for that is because the / separates files inside of directories. Every other character, no matter how weird and the character is allowed inside of a file name. We will get to later quizzes with files that have particularly evil names that will be very awkward to work with. Good question. Any other questions so far? Last problem then, number 4. We'll go ahead and reset for this one. Control R, get back to my big CD command. And so get init and then 3 echoes. So get init, echo, print, hello world. And is this into foo.py? Echo print, is it hola mundo? Double greater than bar.py, is this correct? Yes, I think so. And then echo print, and here it's with the escaped quotation marks right here. This was hola otra vez, escape quotation mark, single arrow bar.py like that. So we're on line 8. We just finished line 8. Now lines 9. We're going to add both of those files and commit. So git add foo.py, git add bar.py, git commit -m first commit like that. And so we've just finished up to line 11 right here. We'll create a new branch foo, check out that branch. Git branch foo, git checkout foo, and line 14 now, modify the foo.py file, print hello again, and add and commit. Echo print hello again, and that's double arrow foo.py, git add foo.py, git commit -m second commit like this. And now we've on line 16 right here, ready to finally see our final answer, 17. Before I actually run it, let's do a cat on the file bar.py. here, what's going to happen is, so these are the only two lines that are directly modifying or outputting something into bar.py. This first one, bar.py, doesn't exist. So the fact that we're appending doesn't matter. It'll create the file and put in hola mundo. Then the second one right here, a single greater than sign, not appending, but delete the contents of bar.py. So ignore what we did up here and put it into bar.py right here. We have the weird escape marks right here. So it's just literally putting the double quotation marks and then add and commit. We don't change these files anywhere else. And here, when we do the commit, there's no like time travel anywhere in this Git session. We're in the foo branch now, but because the foo branch started off from the master branch, it was, we say it's based off of the master branch. It contains all the changes that happen in the master branch. So in particular, it contains this file right here. Hit enter, you can see that it contains that content right there. And so when I run this file, python3 bar.py, we get hola race, and that's the final answer. Any questions about problem number 4? Or any of the other questions on the quiz? Or anything at all? Okay, total up your points and get those papers passed up to me. While you're doing that, today in class, where did it go? There it goes. There's this folder inside the topic 2 Docker folder, Docker example. We'll be going over that in a little bit. So you'll want to make sure that if you're following along, that you have access to that folder, probably by running the Docker pull command inside of your GitHub repo on the Lambda server. So something like git pull origin 2023 spring. Is probably what the command will look like for you to update that. Before we get into any other quizzes that I don't have yet. Okay. Before we get into the technical stuff for today, just some quick administrative notes. This week, there's no special different homework assignments. Instead, I just recommend you keep working on use the time to work on the Twitter MapReduce homework. We will have a lab assignment due on for this week, for this Friday. It's partially posted, not all of it is fully posted yet. But the basic idea of this lab is there's this link over here that's has some basic instructions on what's called Dockerizing an application. Flask over here is a Python framework for making web pages. And so Dockerizing a Flask application means using Docker to deploy or make available your web page that was written in Flask. And so it has some basic steps over here. It's not too long, but there's a lot of potential like pitfalls in the lab here. So historically, this has taken students, I don't know, much longer than they thought it would to complete the lab. It's only like, I don't know, 3 pages of instructions, but it historically takes a long time. What we're building up to with this, again, is next week, we're going to be talking about how Instagram manages all of their web infrastructure. They use Docker internally, along with a Python framework called Django. It's kind of the predecessor to Flask. Flask is a more popular one these days. So most modern tutorials use Flask. And then they use a database backend called Postgres. So next time we'll be talking about how to make multiple Docker containers working together that have different parts. And then after next week, we'll be focusing on this Postgres database and how you actually store your information and work with it efficiently. But in order to be able to do all that, we have to be able to get Docker running. So that's the purpose of this lab and what we're building up to. Any questions about anything administrative or big picture? Okay. Yeah, so I'm switching over to a terminal session now. And I have two windows open right now. They're both in my Docker 02 folder. If I type ls here, I have this docker-example folder available. And if I cd into that, I'll do that on both of these terminals, cd docker example. You'll see that there should be two files in there. And so if you're wanting to follow along, these are the two files that you should have. You won't need these two files for the lab, but the basic procedure that we're going to go over now is sort of the how you use Docker to or basically what Docker does. And so these steps about what we're doing, you'll be reproducing in the lab on this Flask web server thing. This will probably take about, I don't know, a half hour or so, and then the rest of class will start going over the quiz material for next week. What we're going to see when we're talking about this Dockerfile thing here is inside the Dockerfile, there's a bunch of Posix shell commands, and the quiz material for next week contains a lot of information or a lot of patterns that are commonly used inside of Docker files. So a lot of the things that we'll be going over, you will see in the instructions for this week's lab and next week's lab. And that's the motivation for having this material as the quiz for this week. Any questions on the setup, where we're at before we get started? Okay, so last time with Docker, we saw two different commands, and they are the Docker PS command. This command shows you what we call them Docker containers, what Docker containers we have currently running. And so currently I have no Docker containers running, so the only output here is like the header information of a big table. We also saw a command, Docker run, that can start a new container. And every time I say the word container, you should think of it like a virtual computer that exists somewhere, but we don't care where it exists. It's just a computer that we can connect to that's different than the Lambda server. And the particular Docker run command that we saw last time was Docker run space -it space Ubuntu, like that. And we'll go ahead and just hit enter for now. The reason I was hesitating is because this command is spilling over onto multiple lines because my prompt over here is so large, because I'm in a subdirectory like this. But now you can see, like down here, I'm in the Docker container, if up at the top. So totally separate terminal window. I now run Docker PS. This I know is in the Lambda server because I have this green prompt over here. It specifically tells me Lambda server in the prompt over here that I'm connected to. We can see now there is one line down here, which is the container that I am currently running down here. And down here, I know I'm not in the Lambda server anymore because my prompt over here does not contain the word Lambda server, but also more obviously, it's just black and totally formatted differently. If I type pwd over here, you can see I'm in the root folder over here. If I type ls over here, here's the contents of my root folder. There's a home folder. All these folders are pretty standard on Unix systems, but if I do ls home like this, you can see there are no folders inside this home folder. This container has no user accounts. But up here, if I were to do something like ls/home, find what are all the contents of the home folder on the Lambda server, totally different files. So you should think of a Docker container as just like a totally separate computer, has totally separate files, and the commands available to it are also totally different. So most of the standard Unix commands, every POSIX compliant command is available. So like the ls, pwd commands, cd commands, those are all available. But other commands are not available. So one command that's a very useful one that's not available is the Python 3 command. So this container does not have Python installed on it. And in order to make this computer do something useful, we'll have to install Python. Ubuntu is, well, it's a good time to stop and see if there's any questions. Yes?
Yeah, when I try to like start Docker and do the run, I get like the Docker.
I'll have to look at that afterwards. That sounds like a complicated error. Is that happening to a lot of people? Not being able to run Docker PS? Hands up because it's happening or something different?
No,
Same. You can run Docker PS, but not Docker run. Is that what's happening to both of you? That sounds like something different. That sounds like the Docker container is running. If you can't run the Docker run command, one thing to check, what my guess would be, so if Docker PS is working, but Docker run is not working, the most likely culprit is that when we're installing Docker in the bash RC file at the very bottom, we added a line like this, export Docker host. Docker host is how all those Docker commands work together. And so the most likely culprit is that there is something wrong with that. I'm just curious, how many people like have been able to follow along so far on everything? Anybody? Couple, 4 or 5? Pretty much everybody else is having errors on something? Okay. So this is what, yeah, one of the things about Docker is that it is like just weird, difficult to install, and it can break. It's very fragile. It can break if things just aren't installed perfectly correctly. So either after class or we'll have a chance on Friday. I'll make sure that everybody's Docker is back working. We're gonna, the high level things that we're doing today with Docker, it's, I guess, yeah, since you're not going to need these particular files, the important thing is just to get the sense of what these commands do so that you'll be able to do the lab after you get Docker working. But again, after, I don't know, 20 more minutes or so of this, we're going to switch over to talking about the quiz or the practice problems. And then at that point, everything should work for everybody. Any questions about anything other than error messages? Okay. So here, this bottom container does not have Python installed, and so somehow we have to get Python installed onto this container. Ubuntu is what we call a Debian-based system. So Debian is like the flagship Linux distribution for the GNU for GNU, and it's the most open source free software-ish operating system. Ubuntu also includes a bunch of proprietary code that makes it things easier to use. So a lot of people like to use Ubuntu instead of Debian. But any of these systems, you can use apt-get install to install a program like this, apt-get install Python 3. If you do this right away, you're going to get this error message and saying that it's unable to locate the package. And so there's always something else that you have to do first of apt-get upgrade. And these, sorry, not upgrade, updates. These commands are in the in that lab. It'll walk you through exactly what commands to run. Here, though, important weird thing is that for some reason the Ubuntu image, we call the thing, so I just press Control D right here to exit out of my container and back to the Lambda server, press up arrow to get to my Docker run command. The thing over here after the -it, after the run, this is called an image. The Ubuntu image gets downloaded from Docker's website, and the current Ubuntu image has a problem with it where it can't actually install things. So we'll go, instead of using Ubuntu, use Debian here. And Debian does not have this problem. On Debian, you can also see does not currently have the Python command, but I can do this apt-get update. It's not going to throw any error messages. And then apt-get install Python 3, and it'll ask me if I want to install it. I'll say yes, and then I'll have Python 3 available. The question is, what is the image that I'm using instead of Ubuntu? And it is Debian, Debian. And that installed things, and now I have access to Python 3 and can run whatever Python commands I want to run. So anytime you're working inside of a Debian container and you want to install something, it's always apt-get update and apt-get install the name of the thing that you want to install, so Python 3. Again, the update is just contacting the Debian servers, asking them what packages are available, what are their current versions, and apt-get install actually does the install right here. If I do these commands, and so now I have access to Python in my container down here. Containers are what we call ephemeral. So that means that any changes that we make to this container will not last after the container dies. And the container will die as soon as I exit out of it. So up here at the top, I'm going to write Docker PS. We'll see that we have one container here running. The image right here is Debian. And as soon as down here I exit out of the container, type exit, up here Docker PS, we see that the container is not running. So whatever changes I made to that container, like installing Python, they no longer exist. If I press the up arrow to rerun my Docker run command with Debian and hit enter like this and try to run Python 3 again, we'll see that command's not found. And so I would have to reinstall it again in order to use Python. And the takeaway message from this is that containers are ephemeral, is the key vocab word, which means that changes do not persist, which means that every time you leave, everything is deleted. This turns out to be like one of the really powerful things about Docker and one of the really awkward to use things about Docker. It's powerful because this is the feature that allows, like, if you write code that works in Docker, then it will work no matter where you want it to run. You can run it on AWS or Microsoft Azure or any of these cloud systems, or you can run it on the Lambda server or on your own laptop, and it's guaranteed to work everywhere. So that's the good thing about this. The bad thing about this is it just makes things a little bit harder to work with. Anytime we have one of these commands, like installing Python, that we want to have happen consistently all the time, we have to do what's called build another image that's going to automatically install Python for us. In order to build one of these images, we create this thing called a Dockerfile. So again, in the Docker example folder, there's these two files, Dockerfile and infinite.py. And so I'm going to open up the Dockerfile in the bottom window, and we'll see what the contents of that Docker file is. This from command right here, from Debian, means that this is like doing the Docker run Debian command. This is the original image that I'm using to base my new image on. Debian is the original or base image that I'm starting with. Every command that starts with run, every run command is going to be run automatically for us in the terminal. So we saw before that I ran this apt-get update and this apt-get install Python 3 commands in the terminal because I needed to install Python 3 in my container. And so by putting these run commands in the Docker file, it's like automatically typing those in for us. The copy command right here will move, so copy moves a file from the Lambda server to the Docker container. So we're going to try to run this particular Python file right here. And in order to run it, we're going to move it. We have to move it from the Lambda server to the container because we saw that the container does not have access to any of the information on the Lambda server. It has its It's a totally separate computer. And so this copy is like sending it over the network, over the internet to this new location. The leftmost location, the leftmost parameter is the location on the Lambda server. And the rightmost parameter is the location on the Docker container. So here, the ./infinite.py, this is what's called, again, a relative path because it does not start with a slash. So this will be related to whatever the current working directory is. So whatever the folder is that contains the Docker file. This folder contains the Docker file and it contains this infinite.py. So this right here refers to this infinite.py. This slash over here means that we'll copy the file to the root folder, the slash folder, onto the Docker container. And then this command down here, this is the command that gets run when we do the Docker run. So here, it's going to run Python 3 on the infinite.py command. Infinite.py, let's go ahead and open that up. Vim infinite.py, it's just a simple infinite while loop that runs forever. So it's not doing anything interesting. In the lab that you'll be completing this week, your file will be more complicated than this. It will have an actual web server running that people can connect to, and it will display some information. I'll run this Docker file here in a second, but before I do that, are there any questions about what the commands in the Docker file are trying to do? Yes. Yeah, good question. Up here, the -y, what does that do? And why didn't I have it before in the commands that I was typing manually? So anytime you are in a scripting environment where you are running shell commands without user input, it means that there's no way for a user to provide input. So the apt-get update command by default asks the user if they really want to update the system. Because it is a potentially dangerous command. If something goes really wrong, it could hurt your computer. The -y over here just means like automatically press the yes button so that it automatically does that. This is in a container. We know we want to actually update the system because there's nothing in it yet. So it's not dangerous. So we definitely want to do it. Similarly, the install command will show all the actual versions of things being installed and ask you if you actually want those versions. And adding the -y over here just says, yes, I actually want to install it without needing user input. Good question. Yeah. From Debian means that it's like doing docker run -it Debian like that, and then typing these commands into this. If instead of from Debian, I had from Ubuntu, then it would be docker it Ubuntu. The Debian and the Ubuntu images happen to be like very similar to each other, but there are other images that we could put here that would have a lot more stuff pre-installed on it. So one of them that you could put here is from Python, in which case it would automatically have Python pre-installed, and we wouldn't have to run these installation of Python steps. Did that answer your question? Oh, yes. Left, right. So slash is the slash location on a computer. On Unix systems, so if I do like cd/ over here, type ls, slash, all files start from slash. We call this the root of the computer because everything somehow belongs to root. And so this is the place on your computer that has no parent. I do cd-, it'll take me back to where I previously was. Yeah, if that's still not making sense, then I can do a more detailed explanation later. Okay, once we have one of these Docker files, so I'll save and quit out of this, we have to do a two-step process to actually run the Docker file. The first step here is that we have to do what's called compiling the Docker file or build the Docker file. And we do that with the Docker build command. Docker build takes a directory as its argument. And so it is standard practice to do Docker build and dot being the directory that you're currently inside of. And so you always want to be inside the directory that contains the Docker file when you run this. That way, when the Docker file has these relative paths, it will look inside of the same folder. So Docker build dot. The first time you run this, it'll take a little while to do it. But then the Docker program, one of the powerful features of it is that it caches all of these intermediate steps. And so it doesn't, the subsequent times that you run it, it'll be very, very fast. And then in order to actually run this new container, type Docker run down here. And then this right here is called the hash of your image. When it says successfully built, this thing right here is the hash of the image. This is our identifier. And so I run Docker run like that and hit enter. And now it is running that container. If up here I type Docker PS like this, we can see that that container is in fact running. It's very common with Docker containers to do what's called running them in daemon mode. In order to stop this Docker container down here, I'll have to actually use a Docker command to stop it, to terminate the process. So here I said Docker PS. This is the ID of the container down here. If I want to stop it, it's Docker stop, then the hash of the container ID, this thing right here. Do that. Do. There we go. PS, and it is stopped. It's very common to want to run containers in what's called daemon mode. Daemon mode means that it's not going to take over your terminal, that as soon as you finish running it, it's like pressing the Control-Z and sending it to the background. And so this -D flag will run the container in daemon mode, giving you access back down here to the terminal. I type Docker PS, and now I have this container ID with this image. I can run multiple containers with the same image. So now I have two different containers running with the same image. Up on the top, when I run Docker PS, this is the same image, my Python image, and it's two different container IDs. I can connect to these and run commands using Docker exec -it, the hash of the container, then the command that I want to run, bash, type ls. And so here's my infinite.py in my root folder right here. I'll do a quick touch hello like this, ls, there's hello. Let's make it easier to find. It'll be in the top left. These A's right here, type exit out of that. That was in this container right here. So if I go back into that same container, those changes will still be there. But if I go into the other container, so this container right here, the hash starts with 45. So it's the first container ID up here that I went into. If I delete this hash and replace it with a different hash, I'll go into a different container. And if I type ls, you can see those files don't exist down here. If I do touch, add a bunch of B's, ls, now the B's exist in this container. But they won't exist in my 45 container, the hash that starts with 45. They won't exist in that. Only the A's do. And now only the B's exist in that container. So it's like two different computers are running. They just happen to have the same things installed. So this Docker system makes it really easy to start up many, many different computers that have the same sort of like base state. And we will see that Instagram uses this to dynamically load however many web servers they need based on how many connections they have at a given point in time. And you'll be able to do that here as well next week. Any questions on what's going on so far? Yes.
So with exit, is the only reason it doesn't close is on the mode? Like when you exit, before you exited,
Yeah, it's a great question. The question is here when I run the exit command, it is not actually stopping the container. It is just stopping my session with the container. But previously when I was running the exit command, it was not only stopping my session with this container, it was also stopping the container itself. The difference is when you run Docker exec, Docker exec is like doing an SSH session into the Docker container. And so Docker exec will not end the container when you exit. But when you do Docker run, this is like actually starting a new computer, and it'll open up the session. And so when you close the session with Docker run, then it's going to actually shut down the computer. The Docker run with the daemon flag is commonly used with Docker exec to create the sessions. The Docker run with the IT flag, no daemon flag, commonly used without Docker exec, just one session at a time. You're never going to be quizzed on all of these weird different Docker things. So there's nothing to memorize here. It's just something that as you're work through all these tutorials, you'll get a feel for like what's the best workflow for you when manipulating all of these systems. Does that answer the question?
Yeah.
Follow up? Question is, so in this command right here, what is this bash doing at the very end? And this very end command is after you connect to the computer, what is the program that you're running when you connect? So when I run bash, that opens up, let me redo that, exec-it. So let's connect to the 45 hash. When I run bash like this, the program that it runs is bash, the shell that it runs is bash, and so it lets me run the bash commands right here. I might, instead of wanting to run bash though, I might want to run Python, and now I have a Python shell open on the computer. And so I can run things like print hello, and that's happening inside the Docker container. It might be the case in the future, it will be the case in the future that you will want to run non-interactive things, programs that exist down here, and then they'll just be like running in the background. You can run maintenance jobs on your web servers, for example, that way, and not have to be interacting with them. So this, for Docker exec, it's the -it, then the hash of the container you're connecting to, and then the command that you want to run on that container.
And then to switch Python, you exit, and then you run it.
Yep, and then, so the question is, how would I get into Python? I could, from within bash, run Python, in which case, when I exit out of Python, I go back to bash and then back to the terminal. But if here I typed Python instead of bash, then I would go straight to into Python, and then when I exit out of Python, I just leave my session of the container. Yeah, good questions. The lab will have you doing all of these things again on a real, very simple Docker system. So that'll reinforce these concepts for you. Yes.
Is the ls/a command in Docker communicate the same hidden files as
Question is about ls-a inside of the Docker container. So first, ls. So notice that inside the Docker container, I'm currently looking at my root folder. And if I were to run ls-a, there's just a very small number of hidden files here in the root folder. If I were to change to the root folder on the Lambda server, run ls, you can see even without the -a, we have very different things here because the Lambda server files are totally different than the Docker container files. With the -A, we also get different files, just these two hidden files here. But yeah, the right way to think about this is this Docker program is it's a totally separate computer. Right now it happens to be running on the Lambda server because we haven't told it specifically to run on AWS or a different cloud system. But it's just passing a different parameter to the Docker run command, forces it to run on a different computer. So it's you should think of it as being a different computer. Question is, can we do git init inside of Docker? And by default, git is not in any of these Docker containers. In order to get it, we'd have to do apt-get install git, and then it would install it for us, and then we can get access to git, and then we can clone whatever repositories we want and get access to code on the Docker container that way. Great questions.
You said that we reinstall stuff every time.
And any commands that you type into the Docker container are ephemeral. They will go away. If you wanted Git to be installed permanently, you would have to modify the Dockerfile to change this to not just install Python 3, but also install Git, something like that. And then run your Git clone commands or whatever other commands in the Dockerfile. I want us to move on now to the practice quiz material. Because some of this is going to be relevant for the Docker commands that you'll be seeing in the Dockerfile. So in this practice quiz material, still going over Posix shells and how they work. And this section is, I think, the most confusing of the Posix shell behavior to learn at first. But once you get the hang of it, it'll click and make sense, and it'll be easy from then on forward. There are lots of things in the Posix shell that seem easy at first and then are actually really complicated under the hood, how they work. This one's sort of the opposite. It'll seem really hard at first, but then it'll click and be easy. The first thing is, so we saw these semicolons before for just combining multiple commands in one. So all the quizzes from here on out will have that as the first line. And now we've seen creating variables, line 2. Line 3 here is the first new thing. These left arrows like this, less than signs, mean input redirection. And here, a double less than sign is what's called a here file. Let me reset this, just run those first commands, cd, is it foo equals hola, and then that starts what's called a here file or a here document. And so the here means that like this is a file that is right here that I'm putting into the terminal directly and not actually getting it from a file. So what this is going to do, if I do cat and then greater than foo dot, what did I call it? Quiz.sh, EOF like this, put it in quotation marks like that and hit enter. Then you can see that the prompt changes to the greater than sign. I type in hello world and then EOF down here so that this matches this up here and hit enter. Then the contents, what cat outputted, will be just hello world, whatever was between these two lines. So cat quiz.sh outputting hello world like this. The tricky part about this is how it interacts with our variables. I'm going to redo this command up here, but instead of doing hello world, I'll do hello $foo, or we'll do $foo world like that. So foo up here is currently equal to hola. And so our question is it going to do substitution here on this variable and plug it in or not? Hit enter and then cat quiz.sh, and we can see that it did not do variable substitution right here. The reason it did not do variable substitution is because this string, this EOF, is contained inside single quotation marks. If I redo this here document, but remove these single quotation marks like this, no single quotation marks, hit enter, up arrow, then you can see that the variable substitution does happen. So again, The fact that it's single quotation marks makes sense because variable substitution does not happen in normal strings with single quotation marks, but it's a little bit confusing that it's around this EOF and not like around the entire string that you're creating. Any questions about the difference between these two types of here documents? Yeah.
Just in general, does there have to be no space between the little arrows?
The question is, does there have to be no space right here? And the answer is no, it's just whatever comes next is the thing that does matter is, so this EOF doesn't have to be EOF, it can be whatever you want, whatever, but then you must type whatever down here. Whatever it is that you type right here has to match exactly the very last line of your document. EOF is traditional because EOF stands for end of file, but it doesn't matter whether there's spaces or not in front of it. Okay, so that's just sort of like the setup for this problem, because we need to be able to create a multi-line thing right here with the if statement. And so in order to do that, cat quiz.sh and I think it was in the quotation marks EOF. I want to create another foo variable down here. Foo equals hello, foo equals hello, and then if $foo equals hello like that, then touch if v. There were double quotes here? Okay. In this case, it won't matter because there's no variables inside, so the double quotes will be equivalent to single quotes. So now the question is, if I do cat quiz dot here, will this be substituted? Will this $foo right here be substituted or not substituted? And recall again that, so I press Control C instead of hitting enter, echo $foo. Currently our foo variable is set to OLA outside of the quiz.sh file. But inside of the quiz.sh file, it's going to try to set it equal to hello. If I run cat quiz.sh, we see that it did in fact not do the variable substitution right here because I had the quotation marks around EOF. So down here, when I run, I'll type sh quiz.sh. This is one of almost the end of the quiz. This is going to actually run this quiz.sh file by basically copying and pasting each of these lines individually into the terminal and seeing what happens. Run that. And now the question is, did this line right here get run? Touch if. The very last problem of line of the quiz, ls, shows the output of ls. And here we can see there is a file named if. So that means this line right here did in fact get run. So this $foo got interpreted to be the hello assignment right here, rather than the OLA assignment that's in my outside, oops, that's in my current bash session right here. So that's like just the I don't know, framework of the problem. The specifics of the if statement syntax are that in the Posix shell, the condition that you have is inside of square brackets, and you use a single equal sign to check equality between the thing on the left and the thing on the right. Any questions about that? Okay, things will start getting more confusing. Don't worry, we're only started. So here, what if my foo variable is a multi-line thing or a multi-word thing like this? Here, when we do the substitution right here, the substitution will happen with hello space world. And so we'll get hello space world right here. Check to see if that is equal to hello space world all inside of quotation marks. The answer is this will not be equal. This will not be equal. And so this file will not get created right here. The reason it will not be equal is because it's not in quotation marks. It's not going to be a single parameter to this equals. If I run ls-rm the if file, so it's not there, existing there, we'll just cat the quiz.sh so we can see it. And now I run sh quiz.sh like this. You'll see that we get this weird error message about this unexpected operator, because up here this gets expanded into two different things. And so this is not going to be a true statement. This is not going to be run. I type ls, we only get the quiz.sh file. So for the purposes of the quiz, you have to be very careful about looking at the if conditions, checking the quotation marks, whether things will get expanded the way you think they will or not. For the purposes of writing your own shell scripts or Docker files, 99% of the time, you always want to put your variables inside of double quotation marks like this, so that when the expansion happens, it'll still be treated as a single unit of text. And now if we do this, that will in fact be equal to this thing over here. And if I run quiz.sh, it will be true, and we will get the if statement down here, or the if file created down here. One last comment about this problem before I move on. This if statement is what we call a keyword in the Posix shell. Most programming languages, you are not allowed to reuse keywords for other things. You can't use a keyword by itself, and say for Python, you can't have a variable named if. But in the Posix shell, it's perfectly okay to have keywords that are not operating in their normal function. So this if right here is not creating a new if statement. It's just literally the name of the file that touch will create. And then because Posix people want it to be clever, their ending of if was feed, just if in reverse. Any questions about the if statements so far?
So something like, you just say if you just have
The question is, if we had something like if $foo like that, and touch test fee, whoops, fee. You can do that. We're not yet in a position to talk about exactly what that means. Yes, Nico. Question is, are there Booleans? There do exist. So let's, instead of touch, let's change this to echo for a second. And so we'll change this command to something like a equals a. Here, this will evaluate to true. And so this echo test will get run. If we change this to like a not equals a, that'll evaluate to false. This will not get run. Or if we change this to put the not outside of the square brackets, that'll also not get run. It turns out there are a true command. If true, then it'll get run. And if false, then it won't get run. These are not normal Booleans. We'll talk a little bit about what's actually going on under the hood here. But the Posix shell has no, it only has a single type inside of it. It only has strings that exist. And so there's no like a Boolean type like exists in Python or other programming languages. The if statements, if you want to do like an and condition, a equals a, you do double and like this, and then another square brackets, b equals b, then that will also get run. If we have any of these, either of these two conditions evaluating to false, this thing won't get run. If you want to or your conditions together, then double or like that will make it get run. Parentheses will also work how you expect here in these conditions. So b equals b and true, something like that. That will work how you expect. Although again, it's something a little bit weirder that's going on under the hood. think this covers all of section 1 of the practice quiz material. So that's a good spot for us to stop. And then on Monday, we'll pick up with finishing up the practice quiz material. And again, Friday, we'll have the lab session. If people are having error messages with Docker, then I can take a look at those now, or if you don't have time now, then on Friday during our lab class. That's it for today, and I will see you all next time.